Okay, girls, I'm going to try to use videos to write the notes of chapter 2.4. The particle model can be explained by the properties of matter. So this is your title. Please notice that you have 2 underlines. And then we're going to go into the next one. So this goes directly below your title. I encourage you to first watch all the videos so that you can understand all the material, and then you watch it again, and then you take notes in your notebook, okay? So the physical properties of matter can be explained by understanding how particles move. So if we understand how particles move, so the important part is that if we understand how particles move in an object, that's those tiny particles that create that object, then we're going to be able to explain the physical properties, okay? Which physical properties are we going to talk about? Strength, hardness, viscosity, compressibility, and density. Okay, so let's start. The first one is about strength. So strength, what does it mean? It means how much force, so how much force the substance can withstand, okay? And in the book, they talk about 2 types of strength. The first one is tensile strength, and this refers to if the object will break when stretched. So when we're talking about tensile strength, we're talking about if the object will break when it's stretched, okay? Now I'm going to draw something here. Pen, and I want it to go black, okay? So I'm going to draw, this is an atom, okay? And this is another atom. So when we're talking about tensile strength, we're talking about the bond between these atoms, okay? These atoms are connected, agree? And that bond, depending on how flexible this bond is, depending on how flexible it is, it will define the tensile strength that it has, okay? The second force that they talk about is compressional strength. And compressional strength talks about if the object is going to be crushed under large forces. Okay, so I'm going to give an example about these two of objects. So, example. Oh, I wanted red. Okay, here we go. Example. So, if we talk about concrete, so concrete, cement, I'm not sure if you have seen it, it's used in construction and it's quite strong. So if we talk about strength and you think about, let's say that I have, this is made of concrete, okay? And I have a strong, very strong person. I'm going to make it a very heavy person here in top of it, and it stands in top of it. Will this break? No, because it's quite strong, agree? So that's with concrete, it's very strong, so it's not going to break, it's not going to be crushed, agree? So it's not going to be crushed. But what happens if it's pulled apart? So if someone is here, like a very strong person, and another person here, okay, so it can be break if it's a stretch. So which type of strength this one has? This one has compressional. So concrete has compressional force, strength, compressional. Okay, I'm going to wrap this bit that I just drew here because I need that space. Can I draw it? erase out. Yes. Okay. Now, another material we're going to talk about, steel. And if we think about steel, now I have a person, the same person here, the same person, steel is much thinner, and I have a strong, very heavy person on top of it. So if that person stands within, the steel will bend, okay? And it can eventually get crushed, okay? But if I have two people stretching it up, that it doesn't break. So which type of strength this one has? Steel has tensile strength. That's why in construction they use something that is called reinforced concrete. And in your book they talk about, there's an example about reinforced concrete when they use steel as a grid to put things together, and then they pour in concrete. So for example, the floor that we are standing up in the moment is very strong because it has a combination of steel and concrete, and therefore it can withstand both when it's stretched and when it's crushed. Okay, girls, I'm going to stop here and you can see part 2 of the video for the rest of the physical properties.